Hey everyone, in this video we're going to continue what we talked about in our last video with trig functions within a unit circle. More specifically, we're going to be focusing on the 30, 60, 90 triangles. Now, this idea here we've already talked about a couple of times, so if you need a more in-depth explanation, you can feel free to go back to our last video. Remember, unit circle, we're talking about a radius of 1. That means that sine is basically the y value, cosine is going to be the x value, cosecant, the reciprocal of sine, is going to be 1 over y, and secant, the reciprocal of x, is going to be 1 over x. Remember, not super important until you get to a pre-calc level. This is more from an algebra 2 standpoint, but keep that in mind. So steps for finding a designated angle in the unit circle. I know we talked about this in the last video. I want to emphasize it again. We're going to draw the angle in standard position. We're going to find the reference angle. The reference angle is always going to be 30, 45, or 60. In this video, we're focusing on the 30 and the 60-degree angles. Last video had examples with 45. And then we're going to find the designated trig function. Huge thing we got to be careful of is to watch the signs. Remember, if you're in the first quadrant, that means from the origin being 0, 0, you are moving right and up to plot any point in here. Right and up are both positive directions. In the second quadrant, you are moving left and up. Left is a negative direction, so all your x values are negative. All your y values are going to be positive. In the third quadrant, you are moving left and down. Those are both negative directions, so every x and y value is going to be negative here. And then in the fourth quadrant, you are moving right and down, so that's a positive direction in the x and a negative direction in the y. Remember, the hypotenuse is never negative. We're only talking about the x and the y here. So in a 30, 60, 90 triangle, remember, this is my smallest angle. It's across from my smallest side, so I give that x. 60 is my bigger angle, so it's across from the bigger side. That's x radical 3. And the hypotenuse is always across from the 90-degree angle, which in this case is 2x. Like in the last video, we want to make sure that we are giving these actual numerical values so we can evaluate them. And we want to use the easiest values we can. So instead of x, I'm going to use an x value of 1. 1 times radical 3 is radical 3. 1 times 2 is 2. Just make sure you're careful with the signs. So 330 degrees is an angle here. All the way around is 330. Remember, I draw up or down to the nearest x-axis. 330 is 30 degrees away from 360. Remember, the theta, what we're focusing on, is always the angle that's next to the origin. Yes, it's a 30, 60, 90. I don't even bother writing in the 60 degree because when I have 30 drawn there, that tells me that's my reference angle. If nothing else, you can also draw a theta in there to help you. So across from the 30 is 1. Across from what would be the 60 is radical 3. And across from the 90, the hypotenuse is 2. Check your signs to be safe. I've moved right and down. Down is a negative direction. This 1 becomes negative. CSC, cosecant, is the reciprocal of sine. Sine is the opposite over the hypotenuse. So this is the hypotenuse over the opposite. Or the r over the y. Radius is 2. The y value is -1, 2 over -1. The cosecant at 330 degrees is -2. You can always check these values by plugging them into a calculator. Just make sure that if it's degrees, your mode is in degrees, and if it's radians, your mode is in radians. So for the second example, once again, I'm going to want to convert this to degrees. I'm going to multiply by 180 over pi. My pi's are going to cancel. That gives me -180 over 6, which is just -30 degrees. Now, -30 degrees is actually the same as a positive 330 degree angle. So I have a right angle here and a reference angle of 30 degrees. Across from the 30 is 1, across from the 60 is radical 3, and the hypotenuse is 2. As always, we want to check our signs. I've moved down, which means the 1 needs to be a negative. Cotangent is the reciprocal of tangent. Tangent is the opposite over the adjacent. This is the adjacent over the opposite, or the x over the y. The adjacent, the one next to the 30 degree angle, is radical 3. Opposite is -1. Cotangent at negative pi over 6 is negative radical 3. All right, and lastly, 2 pi over 3. I'm going to convert. So times 180 over pi. The pi's cancel out. 3 goes into 180 60 times. So that's 2 times 60, or a 120 degree angle. If this is 120 degrees, remember you draw either up or down to the nearest x-axis. That's 60 degrees more to get down to the x-axis. So now my reference angle, my theta, is 60 degrees. So across from 60 is radical 3. Across from the 30 is 1, and across from the 90 is 2. As always, we want to check our signs. I've moved left. Left is a negative direction. And I've moved up, so the radical 3 stays positive. The cosine is the adjacent over the hypotenuse, which is the x over the r, or -1. One thing we want to be careful of here is you may sometimes have to rationalize. So if I had taken this same example, but then I wanted to find the reciprocal. Let's say we want of 120 degrees, or of 2 pi over 3. Cosecant is the reciprocal of sine. Sine is opposite over hypotenuse. So this is hypotenuse over opposite, or r over y, or of 2 over radical 3. Remember, can't have radicals in the denominator. We'd have to rationalize to get a value of 2 radical 3 over 3. That's what can make these tricky if you don't watch your signs and if you're not careful to rationalize.